So good morning. Chemistry second year English medium. Unit is surface chemistry. Topic is working of soap or miscellaneous. Okay. So soap chemical name is a sodium salt of stearate. Sodium salt of stearate. Its molecular formula is C17H35COONA. COONA. Then its structure is looks like the CH3 CH2 up to C17, then H35COONA. This is the structure, skeleton form of sodium salt of stearate. Then yes, next one, so it forms the miscellaneous. It forms the miscellaneous when soap is dissolved in water. When soap is dissolved in water at lower concentrations, just it looks like this. Then at lower concentration, sodium salt of stearate, when it is dissolved in water, it forms the stearate ion and sodium ions. It can be ionized as stearate anion and sodium ions. Stearate ions can form the miscellaneous. At lower concentration, stearate anion occupies the surface of water. Then yes, here is at this stage it acts as a strong electrolyte. When at CMC, critical miscellaneous concentration, at a critical miscellaneous concentration, that is for soap 10 to the power of -4 to 10 to the power of -3 moles per liter, then yes, it forms the miscellaneous. It forms the miscellaneous, that is yes in water. Yes, here is, so this is the negative end, that is a hydrophilic end. So COO minus, carboxylate ion ends. Then so these ends are, here is a hydrophobic ends. Okay, hydrophobic ends are alkyl chains. Alkyl chains act as a hydrophobic ends. Carboxylate end act as hydrophilic end. Okay, so these are the hydrophilic ends. Then it forms the, here is a miscellaneous. Miscellaneous is nothing but what? Aggregation of simple molecules. Aggregation of simple molecules to form a colloidal structure, to form a colloidal particle, yes, in which each molecule or each ion is having two ends. One is a hydrophobic and the other one is hydrophilic. Then so this is happened at CMC. Then yes, let's see the stearate ion structure. Stearate ion structure consists of two ends. One is hydrophobic tail, that is hydrophobic tail is nothing but what? It is a hydrocarbon end. Then hydrocarbon end in general, it act as hydrophobic end. Then next one, carboxylate, and it is a polar end, polar group. So due to this reason, it is a hydrophilic head, hydrophobic tail. Then so this is the structure of stearate ion. Yes, it can be written as like this, skeleton form, hydrophilic, then hydrophobic end. Then yes, next one, let's see the carboxylate group in general has, because of its polarity, carboxylate group has affinity for water. It can easily interact with water. Is a hydrocarbon chain of the anion. Stearate ion has affinity for grease. Okay, how the soap acting on, yes, here is a dirt particles or grease particles, how its function, let's see. Then is a hydrocarbon chain, is a, because of its hydrophobic character, yes, it is having affinity for grease or oil or dirt. Then so due to this reason, the tail part dissolves, the tail part or hydrophobic part dissolves in grease. grease. Then next one, the micellar. Let's see the, yes sir, here is a soap molecules form micellar around the oil droplet in such a way that a hydrophobic part of the stearate ions in the oil droplet and the hydrophilic part projects out of the grease droplet like bristles. Then yes, the soap is nothing but what? Yes, sodium salt of stearate. Yes, here is a stearate ion. So this stearate ion is having two parts. One is a hydrophobic end, another one is a hydrophilic end. The hydrophobic end here easily interacts with grease. This due to this reason it can dissolves the grease or dirt on the cloth. Then yes, next one, here is a hydrophilic end. Hydrophilic end in general it is, here is what it is hydrophilic part projects out of the grease, out of the grease droplet like bristles. So this is a looks here is what this is the, yes, micellar formation. Yes, here is this is the oil drop or grease on, yes, cloth. Then next one, yes, here is a arrangement of stearate ions on the oil drop. Then next one is because of its hydrophobic property. Then yes, all hydrophobic ends dissolve in the, yes, dissolves the grease. Then yes, here is what micellar formation takes place. All, yes, soap particles or stearate ions surrounds the yes, what, oil drop. Then yes, so because of hydrophilic character of carboxylate ions, these interacts with water. Then yes, they can pull out the yes, here is oil drop from the cloth then into the water. As a result of that, yes, here is a oil drops or grease can be removed from the cloth. So this is the function of soap. Yes, while cleansing action of soap, here is a micellar formation is compulsory. Okay, so because of micellar formation, here is a dirt particles or grease particles or oil particles are removed from the cloth. Okay, so this is for, then here is a working of a soap.